Hello everyone. So guys, welcome back to the second part of our projectile motion. Projectile motion part 2. As you remember in the previous part, we have discussed two methods of analyzing the projectile motion. One was the vector approach and another was resolving the projectile motion or resolving the curvilinear motion into two perpendicular directions of one-dimensional motion. So in the projectile motion, we have developed the expression for the maximum height attained. We have developed the expression for time of flight. We have developed the expression for. We have also developed the expression for horizontal range, and we have we have seen some results when angle of projection is theta as well as 90 minus theta. The range of the projectile motion will remain same, but the time of flight will be different. The maximum height attained by the projectile motion will also be different, and the relation between R and the relation between R and H1 and H2 was obtained as this, right? So now let us talk about equation of projectile motion. Let us talk about the equation of the projectile motion or the relation between X and Y. Look, this is our ground to ground projection. This is X and this is Y. The particle is thrown with some initial velocity u, making an angle theta with the horizontal. And the motion of the particle is completely under the effects of Earth's gravity or gravitational force of the Earth, conservative force. That is why the motion of the particle is this curvilinear motion. Now, in the horizontal direction, there is no acceleration. It is uniform motion. So displacement or the distance traveled by the particle along horizontal direction is velocity into time. And in vertical direction, the acceleration is constant. So the equations of motion are applicable. All the equations of motion are applicable in vertical direction. The motion of the particle along vertical direction, y direction, will be uniformly accelerated motion or uniform acceleration. So we can say the distance traveled by the particle in x direction is simply u cos theta into t at any time t. At time t. And y is equal to u sin theta t minus half gt square. What we have used? Sy is equal to uyt plus half ay t square. This is the expression. So we are interested in developing a relation between x and y. So this t can be replaced. We can say t is equal to x upon u cos theta. This t, which is equal to x upon u cos theta, can be replaced in the second expression. So y is equal to u sin theta into x upon u cos theta minus half g t square, that is x square upon u square cos square theta. So sin theta upon cos theta, this u will get cancelled out. So y is equal to x tan theta, first term, minus g x square upon 2u square cos square theta. This is one expression of projectile motion or equation of the trajectory. Can we say that here y is a function of x square? When y coordinate is a function of x square, it is the equation of a parabola. So the path of the projectile motion is parabolic, isn't it? The path of the projectile motion will be parabolic, the equation of the parabola. So our expression is y is equal to x tan theta minus gx square upon 2u square cos square theta. We can also write this equation as y is equal to 1 upon cos square theta is sec square theta, and sec square theta can also be written as 1 plus tan square theta. So in terms of tan theta, we can write x tan theta minus gx square upon 2u square into 1 plus tan square theta. This is another form of equation of trajectory of the projectile motion, ground to ground projection. And also, if we take x tan theta common, y is equal to x tan theta 1 minus, if we take x tan theta common, 1 minus gx square into 1 plus, or let me use the previous equation only, this one. We can say gx square upon 2u square cos square theta. Because there was no x tan theta, we can say into x in the denominator, we can write x tan theta. Tan theta is sin theta divided by cos theta. So from here, 1x will be getting cancelled out with this 1x. 1 cos will be getting cancelled out with this cos. In the bracket, it will be 1 minus gx upon 2 u square sin theta cos theta, isn't it? If we see this, u square sin 2 theta by g, it is r. Here it is r. So our expression of y can also be written as x tan theta into 1 minus x by r. 1 minus x by r. So these are some of the equations of trajectory of the projectile motion. Let us discuss some questions related to this. And one more important thing, let me discuss first. You must have seen that for a circular motion, for the particle to have a circular motion, there has to be a component of acceleration along center of the circle. That is called as centripetal acceleration, which is perpendicular to the velocity. So the component of acceleration perpendicular to the velocity will change the direction of velocity. That is how the particle will move along a circle. And what is centripetal acceleration? That is v square by r, if r is the radius of the circle, isn't it? The centripetal acceleration, which is perpendicular to the velocity. Velocity and acceleration are perpendicular to each other. Now, for this, because projectile motion is a parabolic path, try to understand this. This is y direction, this is x direction. The projectile motion is a parabolic path, or it is a curvilinear motion. So any curve can be taken as very small part of the curve can be taken as the arc of a circle. Similarly, this curve can also be taken as the part of the circle, isn't it? This curve can be taken as part of the circle. So a curve can be, some part of the curve can be taken as the part of a circular motion or arc of a circular motion. So when the particle is moving along a circle in a circular path, then there must be a centripetal acceleration which is normal to the velocity. So from here we can easily find out the radius of curvature. The radius of that circle is called as radius of curvature of the curvilinear motion. If we talk about point 1, this is the velocity of the particle u, making an angle theta with the horizontal. So if I assume this part to be a part of a circle like this part is a part of a circle, we can find out the radius of curvature. This is the center of the circle, let us say. This is the radius of curvature r1. So we can say r is equal to, at any point, radius of curvature is equal to velocity, magnitude of velocity square upon component of perpendicular component of acceleration, isn't it? So from here, velocity is in this direction, the acceleration is acting in downward direction, isn't it? We want the component of acceleration along this direction. If this angle is theta, this angle is 90 minus theta, and this angle is again theta. So a perpendicular here will be equal to g cos theta. So from here, the radius of curvature at point 1 can be taken as v square, that is u square upon g cos theta. I hope this is clear to everyone. The radius of curvature of the particle, the radius of curvature of the particle's motion along, the radius of curvature of the particle motion along this at initial position will be given by this. At highest point, this curve can also be taken as arc of a circle. So at highest point, the direction of velocity is only horizontal, that is u cos theta. I hope that you already remember. At highest point, there is no component of velocity in y direction. The only component of velocity is in x direction. And acceleration due to gravity is already taken, is already acting perpendicular to the direction of velocity. So this point 2, if we want to write r2, radius of curvature, the velocity square at this point upon component of acceleration in perpendicular direction to the velocity, that is g. So r2 will be equal to u square cos square theta by g. These are radius of curvature at initial point as well as the point of maximum height. Right? So let us solve one question based on this. The question says, find the angle of projection when there is a target. This is the target, let us say. We want to hit this target, which is at a height of 10 meter and which is at a distance of 20 meter from the point of projection. What should be the angle of projection if the particle is thrown from this point at initial velocity of 20 meter per second? What should be the angle of projection to hit the target? This is the question. Now give it a try. Our objective is that the particle must follow this path. The particle must follow this path. This 10 meter, is it the highest point or maximum height? Or it may not be the maximum height. It can be the maximum height, it may not be the maximum height. If the particle is thrown like this, then also it can hit the target, isn't it? So there are two possibilities of theta. Let us find out those. Can we call this point to have the x coordinate as 20 and y coordinate as 10? This point 20, 10 must lie on the equation of the projectile motion. And what is the equation of the projectile motion? We know y is equal to x tan theta minus gx square upon 2u square 1 plus tan square theta, isn't it? So y is equal to 10, x is equal to 20, tan theta minus g is taken as 10 into x square is 20 square, sorry, x is 20 square into 2 into u square is also 20 square, 1 plus tan square theta. This 20 square will get cancelled out with this 20 square. If we take tan theta as some other variable p, so we can say 10 is equal to 20p minus 5 1 plus p square. The objective is to find out the value of p. It is a quadratic equation. If we divide by 5, so 5 is equal to, if we divide by 5, then it will be 2 is equal to 4p minus 1 minus p square, isn't it? Or we can write it as p square minus 4p. If we send all the terms on one side, plus 3 must be equal to 0. If we can factorize this 4p, we can write it as p square minus 3p minus p plus 3, isn't it? Is equal to 0. P square minus 3p. So it will give rise to p into 1 minus 3. It is p minus 3. Minus 1, p minus 3. So p minus 1 into p minus 3 is equal to 0. So the value of p is either 1 or 3. These are the possibilities. It can be either 1 or 3. So we can say tan theta is either 1. In that case, theta will be equal to 45 degree. In that case, h maximum is equal to 10 meter, or tan theta is equal to 3. In that case, theta is equal to tan inverse of 3. These are the two possibilities of angle of projection such that the particle hits the target. Let us talk about the another question. Next question is, let us say the particle is, there is a wall of height h. The particle is thrown from here, making an angle 45 degree with some initial velocity u. The particle is thrown from a point which is at a distance a from the wall, and We want the particle to go on the other side. This is, let us say, B. The particle is hitting the ground on the other side of the wall at a distance B. Now, the question is, we need to find out the relation between HA and B. The question is, find the relation between H, A and B. That is the question. U is not given. We need to find out the relation between H, A and B. Can we say the value of R, horizontal range of the projectile, will be equal to A plus B? That is the horizontal range, A plus B. Now, this point, at the highest point, is it the highest point? It may be the highest point, it may not be the highest point, isn't it? The particle can go like this. The particle can go like this also. Like this. So B is the point, the distance of the particle from the vertical wall when it hits the ground. So we need to find out the relation between it. So we can say R is equal to A plus B. Now our equation of trajectory is Y is equal to X tan theta 1 minus X by R, isn't it? So this point can be taken as, this is our Y direction, this is our X direction, and this is the point of projection is origin. We always take the point of projection as origin. So this coordinate of this this point is A comma H. So X is equal to A and Y is equal to H. So H is equal to X, that is A tan theta tan 45 1 minus X means A upon A plus B. So H is equal to A minus A square upon A plus B. This is the relation. This is how we can find the relation. Or we can write it as, this is A, then it is A plus B, then A plus B minus A and minus A getting cancelled out. So H is equal to A into B upon A plus B. This is the relation between H, A and B using the equation of trajectory. Can we find out the velocity of projection as well? So we can say Y is equal to X tan theta minus gx square upon 2u square cos square theta. From this equation, or from this equation, gx square upon 2u square 1 plus tan square theta. From this equation, we can also find out u, isn't it? If we want to find out the relation between HAB, then we are supposed to use this equation. But if we want to find out the initial velocity of the particle, then we can use this. Y is equal to H is equal to x is equal to a. 1045 is 1 minus g a square upon 2 u square, then it is 1 plus 10 square theta, that is 2. This 2 getting cancel out, then we can say from here we can write a minus h g a square by u square is equal to a minus h, a minus h. So u square is equal to g a square upon a minus h, and u is equal to under root of g a square upon a minus h. This is how we can find out the initial velocity as well. Okay. So next is velocity of the particle. At any time t, this is y direction, this is x direction, the particle is moving along a projectile motion. Now at any time t, what is Vx? That is equal to Ux, that is u cos theta, we already know. And what is Vy? That is Uy minus Gt. We can call it as u sin theta minus Gt. So the vector velocity vector, which is Vx I cap plus Vy j cap, which can be written as u cos theta I cap plus u sin theta minus Gt j cap. This will be the velocity. Now at t is equal to capital T, let us say time of flight, at t is equal to capital T, can we say Vx will remain as ux, that is equal to u cos theta, there is no change in u. If we talk about Vy is equal to uy minus gt. What is time of flight? 2 uy by g, isn't it? That is the time of flight. G getting cancelled out. So uy minus 2 uy. So from here we can say Vy is equal to minus uy, isn't it? From here at any time t, this is, let us say, V. It is having a horizontal component Vx, it is having a vertical component Vy. We can find out this angle also. Tan alpha is equal to magnitude of Vy upon Vx. That is tan alpha, perpendicular upon base. So tan alpha can be calculated as u sin theta minus gt upon u cos theta Vx. Right? Now for t is equal to capital T, so the particle, if it is initial velocity is u, making an angle theta, then its final velocity is also u, making an angle same theta. Why the same angle theta? If we talk about tan alpha, that is equal to Vy by Vx mode, that is equal to uy by ux, that is equal to tan theta. Uy by ux is tan theta. So this angle is also theta, because it is having the horizontal component ux, having the vertical component downward direction, right? Now if theta is equal to 30 degree. We can say if the angle is 30 degree theta, this is 30 degree, this is the direction of u, this is the direction of v, this will also be 30 degree, isn't it? So the angle between initial velocity and the angle between final velocity, we can say like this. This is the angle. Like this. This angle will be, this angle will be 60 degree. This angle will be 60 degree from the right, from the triangle, concept of the triangle or properties of a triangle. This is 60 degree, so this angle is 30 degree, so this angle will also be 30 degree. These two angles will be 30 degree. So exterior angle is equal to sum of interior opposite angles. If theta is equal to 60 degree, or if theta is equal to 45 degree, if theta is equal to 45 degree, let us say, so this is the direction of initial velocity u, this angle is 45 degree, then this is also u, this is also u, this angle will also be 45 degree, this angle will also be 45 degree, so this angle will be 90 degree. The angle between both the velocity will be 90 degree. If theta is equal to 60 degree, let us say, if theta is, let us say, 60 degree, if it is 60 degree, look, this is u, it is making an angle 60 degree, so this should also be 60 degree, or we can say this should also be 60 degree. So angle between these two velocity, this is u vector, this is v vector, this angle is 120 degree, isn't it? This angle will be 120 degree. So we can find a point on this projectile where the angle becomes 90 degree, isn't it? This angle becomes 90 degree. We can find out the time where the angle between v and u becomes 90 degree. So we can say if theta is the greater than 45 degree, when the angle is greater than 45 degree, then there is a point at some time instant t, u becomes perpendicular to v, otherwise it will not become perpendicular. For theta less than 45 degree, it will not become perpendicular. So u becomes perpendicular to v, and we know that if two vectors are perpendicular to each other, their dot product will be 0. So u dot v must be equal to 0. What is u vector? That is equal to ux I cap. So that is u cos theta I cap plus u sin theta j cap. What is v vector at any time t? That is u cos theta I cap plus u sin theta minus gt j cap. This will be the expression. Now if we take the dot product of these two, I cap will multiply with I cap term, j cap term will multiply with j cap. So we can say u cos theta into u cos theta, that is u square cos square theta, minus u sin theta into this, so it is u square sin square theta, minus u sin theta into gt should be equal to 0. U square cos square theta plus, it should be plus na, plus u square sin square theta minus u sin theta gt will be equal to 0. So it will be u square cos square theta plus sin square theta is 1 is equal to u sin theta into gt. One u will get cancelled out with this u. The time where the velocities become perpendicular to each other will be equal to u upon g sin theta. U upon g sin theta. I hope this is clear. Let us discuss some advanced level problems based on projectile motion. There is a question. A ball is projected. The question says a ball is projected from the ground at initial angle of 45 degree. At 45 degree and reaches the maximum height of 120 meter. It reaches a maximum height of 120 meter. Then it will strike again with the ground. And when it hits the ground, it loses 50% of its kinetic energy. 50% kinetic energy is lost when it hits the ground and moves at angle 30 degree. This angle is 30 degree. What is the maximum height attained by the particle after one bounce? This is the question. If we assume the initial velocity of the particle as u, this is the maximum height. So we can say h is equal to u square sin square theta by 2g, isn't it? Right? So we can say 120 is equal to u square upon 2 into 10 into sin square theta, sin 45, 1 by root 2, it will become 1 by 2. So u will be equal to u square will become 120 into 2 into 2 into 10. So u will be equal to under root of this. So it will be 2 into 10 into root 12. This. So u will be equal to 40 root 3 meter per second. This is the initial velocity. And the particle strike with the same velocity. We have already discussed the same velocity at the same angle. Right? Now, during this collision, striking with the ground, it loses 50% of its kinetic energy. So here the kinetic energy, let me call it as u dash. So the kinetic energy becomes 50% of initial kinetic energy. So half m u dash square is equal to 50% of half m u square. Half m getting cancelled out. So u dash square is equal to 0.5 into u square. What is u square? That is 40 root 3. It is u, isn't it? it will become, what is u dash becomes? What was u square? U square was 4800. 4800. So it is 0.5 of 4800. So 2400. U dash square is equal to 2400. So u dash becomes, u dash will become 10 into 2 into root 6. U dash will become or we can call it as, that is 10 into 2 into under root 3 into root 2. Okay, fine. Let me keep it this only. This. Now the height will be equal to u dash square sine square 30 degree by 2g. So the height attained will be equal to u dash square. We could have taken for 2400 into sine square theta. Sine square 30. Sine 30 is 1 by 2. That will become 1 by 4 upon 2 into 10. And 10 getting cancelled out. So it will be, h will be equal to 30 meter. H will be equal to 30 meter. I hope this is clear. We don't require u as such. We could have used this u square only. 4800. U square is 42,800 and u dash square is 2400. One more question. This question was asked in JEE Advanced. Now the question says a projectile is fired with velocity u. U. With velocity u at an angle theta with horizontal. For acceleration is equal to acceleration due to gravity. The range of the projectile motion is d. This is, let us say, d. When acceleration is a by g, the range of the projectile motion is g. D. But at highest point, the projectile at the highest point, the projectile here a is equal to g, but at highest point the projectile enters into a different region with g dash is equal to g by 0.81. The acceleration due to gravity is different, g by 81, g by 0.81. Yes, the new range of the projectile motion here, when the acceleration due to gravity decreases, is it increasing or decreasing? It is greater than g, it is increasing. When acceleration due to gravity increases, then what happens to the range? The range becomes lesser, isn't it? Range will decrease. Up to first part, the particle is moving under gravity, but in the second region, the acceleration due to gravity has increased. G dash becomes g by 0.81. So the particle will move like this. And this is the new range. So d dash is equal to n into d. Find the value of n. This is the question. We need to find the value of n. This is, let us say, h. This is how the particle will travel. Now look, can we write h is equal to u square sine square theta by 2g, isn't it? H. Can we write d in the normal situation? D is equal to, that is the range, u square sine 2 theta by g, isn't it? Let me call this to be x. So can we write d dash is equal to d by 2 plus x? D dash is equal to d by 2. This is d by 2 plus x. Now, if we can find out the value of x, this, the particle is traveling from here to here, again another projectile motion where g is not g is not 10, g is g by 0.81. Now this h, here the particle is having only horizontal velocity. So from here h can be taken as, or we can say, this x is equal to, the horizontal velocity does not change. So can we say x is equal to u cos theta into t dash, isn't it? So t dash will be equal to x upon u cos theta. Time taken during this motion, x upon u cos theta. And h can be written as, h is equal to, there is no velocity in y direction, so ut plus half a t square, h will be equal to half g dash into t dash square. Or we can write it as half then g upon 0.81 into t dash square, that is x square upon u square cos square theta. H is equal to half g dash. Just a second, if I have taken something wrong. Our objective is to find out the value of x. What we could have done is, what we can write is, from here t dash is equal to 2h by g dash under root of this. Yeah. And we can write x as, x is equal to u cos theta into t dash, that is under root of 2h by g dash, isn't it? So find out the value of x. X is equal to u cos theta into under root of, if we put the value of h, 2 into u square sine square theta upon g 0.81. So it will be u cos theta into u sine theta u square sin square theta 2g, 2 getting cancelled out. So u sin theta upon g into under root of 81.81 this. So it will be u square sin 2 theta upon g into 9/10.9 this, and u square sin square theta sin 2 theta u square sin theta cos theta. If we multiply with 2, look, now if we multiply by 2 and divide by 2 here, 2 by 2, so this will become d, u square 2 sin theta cos theta, u square sin 2 theta by g, that will be d. So d by 2 into point, this will become d by 2 into 0.9, that is x. X is equal to d by 2 into 0.9. If we put, this will be our x, if we put the value of x here, d by 2 into 0.9, so our equation will be plus x, that is d by 2 plus d by 2 into 0.9. So d dash is equal to d by 2, if we take common, that will be 1.9. That is equal to n d. So n will be equal to 1.9 divided by 2. 0.95. The value of n will be 0.95. All right. So that is all about projectile motion, or more specifically, it is about ground to ground projection. I hope you have understood the concepts, and see you in the next session. Enjoy, take care, have a great day.